that I'm able to follow like my own interest and bring it to everyone else in the same way.
Great. Wonderful. Okay, so the way tonight is going to run, we're going to have Dr. Murty introduce some sleep, and then Dr. Cowan introduce some more sleep and memory, and then we're going to have questions. So if you have questions throughout this time, don't hold back. We are all about answering questions around here. So feel free to submit your questions to the Q&A, which you can find at the bottom, not to be confused with the chat. And then we'll do that during the Q&A session, and then we'll wrap up right around 8 p.m. Eastern. Does anyone here have any questions before we begin? All systems go. Okay, I'm going to hide. Dr. Murty, take it away.
Oh, a little bit of a switcheroo to start with. So Emily's gonna go ahead and take over and actually talk about a bulk of the work on sleep and memory, as she is the expert on that. And then I'm gonna steer it later into a little bit of a clinical domain in terms of thinking about sort of the applications of it. So take it away, Dr. Cowan.
Well, thank you. Let me just share my screen, make sure this all works. Okay. And can you guys just see the slides? Nothing else? Are we all good?
Yes, all systems are go.
Great. Okay. Well, thanks everyone for joining tonight, and looking forward to this. So we spend an inordinate amount of our time asleep, nearly a third of our lives, in this period when we're relatively unresponsive to the outside world, which seems like it should be maladaptive, yet basically all animals sleep, which begs this question of why do we sleep? Though it seems like sleep may just be a period of inactivity, sleep isn't passive. Instead, active processes occur when we go to sleep. And I hope that one of your takeaways from today is this idea that sleep is active. Sleep functions have been shown to impact things including restoring energy resources, repairing cell tissues, and even the detoxification of brain tissue. So during the day, there can be a buildup of toxic chemicals that then get flushed out of the brain during sleep. This includes proteins that aggregate in Alzheimer's disease. But today I'll really be talking mostly about this last function of sleep, which is its benefits for memory. But before we get there, I wanted to first back up and basically say and introduce what is sleep. We all know generally what sleep is, but more specifically, sleep consists of the structured progression through cycles of stages of sleep, with each cycle lasting roughly 90 minutes. And these cycles can be divided into non-REM sleep and REM sleep. REM sleep meaning rapid eye movement sleep, and non-REM sleep just meaning not rapid eye movement sleep. Non-REM sleep is made up of stages 1, 2, and slow wave sleep. And I'm plotting those on this slightly confusing graph, but I'll talk you through it. This is basically an example of a person's night of sleep, from falling asleep in the evening to waking up in the morning. And what I want you to notice is that there is this progression through these different stages. You can see on the side, you have wake, REM sleep, stages 1, 2, and slow wave sleep. So in stage 1 sleep, that's basically your just falling asleep stage. It's relatively easy to wake someone up during this stage 1 sleep. In stage 2 sleep, the body starts to relax, heartbeat and breathing slow down. And this is actually the stage you spend the most time in, up to half of the night of sleep. Then slow wave sleep is our deep sleep. And this is the sleep that's necessary for feeling refreshed. During slow wave sleep, your heartbeat and breathing slow down further, your muscles relax, and it can be hard to wake someone up when they're in this deep sleep stage. Finally, we have REM sleep, which is called this because of the characteristic eye movements, the rapid eye movements. So if you've ever watched someone asleep, you may have noticed their eyes moving under their eyelids, and that's characteristic of REM sleep. During REM, your breathing actually becomes faster and more irregular, and your brain activity actually looks more like you're awake. REM sleep has been connected to dreaming, but more on that a little later. So animals in general show different patterns or distributions of these sleep stages, but in humans, early in the night is characterized with more non-REM rich sleep, with periods of REM sleep lengthening later in the night. And you can see that on this graph that I'm plotting, where the black parts of REM that are representing REM get wider and longer into later sleep. So sleep is intricately tied to circadian rhythms. This is a 24-hour biological clock that helps set our sleep patterns. Circadian rhythms can influence the production of hormones like melatonin, which helps promote sleepiness. And you can see on this illustration that there are lots of functions tied to our circadian rhythms, and that they regulate our states of or feelings of wakefulness and sleepiness. This clock is set by a region of the brain known as the suprachiasmatic nucleus, which is a part of the hypothalamus. And what's important is that it receives direct input from the eyes, which may be why light is a major factor in setting or resetting your circadian rhythms. And on that note, anyone who has experienced jet lag knows that this is when your circadian rhythm doesn't match to your new time zone. So once you've crossed time zones, and it takes time, days even, to actually reset. And one of the ways that the big ways it resets is the pattern of light and dark in your new time zone. But why is sleep good for memory? So now that we've sort of gotten a basic idea of sleep, well, while we're awake, our brain is bombarded by information. We constantly have new sights, sounds, smells coming at us that our brain takes in and processes through different pathways. But when we go to sleep, we have no external stimuli coming in. So sleep may provide a chance for us to disconnect from our environment, process our memories without having to encode anything new. So it gives us a chance to update our internal models of the world with what we've learned or experienced that day. Research has long tried to understand the effects of sleep on memory. There's been a lot of research on this topic. And there have been a lot of studies that have shown that a period of sleep, either a full night of sleep or even just a short nap, benefits later memory performance compared to if that same period is spent awake. It also seems like sleep benefits our learning ability. So in these studies, a period of sleep facilitates our ability to take in and retain new information, while on the converse, sleep deprivation, so spending that time awake, reduces our ability to learn or take in new information and to retain it. So I wanted to show this. This is among the first of the studies that showed this sleep benefit for memory. And this was done way back in 1924. The details aren't super important, but I just wanted to include it for sort of a historical guidepost of, in this study, in this case, they were memory for learned materials. In this case, it was syllables, is better learned after a period of sleep, which I'm highlighting here in red, compared to if that same period is spent awake. But since that foundational study in 1924, there have been many studies showing and connecting sleep and memory in more nuanced ways. Generally, it's not as simple to just say that sleep benefits memory. Instead, it seems like these dynamic stages of sleep that I was telling you about may differentially contribute to memory. And that's because there are different types of memories. So though I will refer to, and we all refer to memory as sort of a monolith, instead, our brain processes and stores different types of information differently. So in line with that, the field has shown, I'm just showing these stages of sleep again, but the field has generally shown that non-REM sleep benefits episodic memory. So these are your memories for events and experiences that you have. While REM sleep has been related to more procedural or skill learning memories. So this would be something like learning to ride a bike. Sleep has also been shown to benefit emotional memory as well as problem solving, perhaps proving that old adage that encouraged you to sleep on a problem, suggesting that might actually have some truth to it. Okay, so just to pause for a second, what I've just told you is that sleep benefits a lot of different types of memory processes. We also talked about how sleep isn't a singular thing, but instead is composed of distinct stages and cycles, which seem to differentially contribute to our ability to remember different types of information. So that obviously leads to our next question, which is, how does sleep do this? And I'm next going to introduce some of the mechanisms by which we think memories are stored for the long term in the brain and the role that sleep seems to play in that. So to answer this question, we have to back up a bit to talk more about how memories are formed in the brain overall. So we can use this example. Let's say a new ice cream place just opened and you go and get a new flavor. This experience, again, made up of these sights and sounds and tastes and smells, all gets processed by areas of the brain in the neocortex. And this information and signals about this information are passed to an area known as the hippocampus. This is a region that's critical in the formation of memories and that binds together elements of an experience into a cohesive memory trace. We all know that not everything that we perceive or encounter do we actually remember later on. There's a lot of forgetting and there's selection in what we actually can remember and hold on to from any experience. And that's in part because our memories are stabilized and reorganized for the long term through a process known as memory consolidation. And these mechanisms of memory consolidation are still being investigated. In fact, some of what our research is focused on is looking at this very question. But it's thought that the hippocampus and the cortex, the regions I just told you about, work together to form long-term memories. So the new memory traces that were formed in the hippocampus, represented here just with these blue dots to illustrate memories, get repeatedly reactivated during these non-REM sleep stages. And this is a process known as hippocampal replay. And this seems to be important because this reactivation or sort of activating these memories during the sleep stage allows the cortex to build up a representation of that memory too. The reason this is so important is that the cortex can extract information about the experience to build a more generalized memory trace so that the new memory can be incorporated into existing memory stores without interfering with your existing memory. So to take our ice cream example, your memory for this one ice cream cone will be incorporated into your memory for ice cream in general, without overwriting or replacing all your existing memories from before. And the cortex seems to be particularly well suited for that, whereas the hippocampus isn't. So this is a really important interplay between these different brain regions that allows us to hold on to memories for the long term. So what role does sleep play in this? Well, I started to tell you a little that it's, during these non-REM sleep stages. And if you remember, sleep can be characterized by these cyclical stages. But these stages are actually characterized by different types of brain activity. So I know this looks like a lot, but what I'm showing you here is an example of the brain activity in each stage of sleep. So this is the electrical activity as waves, or what we call oscillations. You can think of it like a fan moving or like waves in an ocean. But they're at different frequencies. So some are faster, some are slower and more rolling. What I want to draw your attention to here is just how these waves or oscillations change across the different stages, becoming wider, or what we would refer to as slower, through these non-REM stages, starting from wake to then stage 1 sleep, stage 2 sleep, and slow wave sleep. But then they look much smaller and faster in REM. And that goes back to what I was saying about how the brain actually looks more like it's awake during REM sleep. And what's interesting is, these different oscillations or waves of sleep have actually, a lot of research has then focused on those and found that those characteristics of those waves are related to how we remember. They're the sort of mechanism by which this interplay or these interactions between these different brain regions can talk to each other. So without getting into the details too much, the basic idea is that there's a relationship between these different brain activity oscillations, and that the brain is coordinating these waves so that information, these new memories, can be sort of translated from the hippocampus into the cortex for the long term. And this is an intricate relationship that suggests that beyond just saying that sleep is good in general for memory, that brain activity is actively coordinating this process. And it seems that within non-REM sleep in particular, then, these are characteristics of the neural activity may underlie the stabilization and the storage of episodic memories for the experiences that we have in our lives. So one of the biggest questions I get asked as a person who studies sleep is, how does this relate to dreams? And so evidence actually suggests that we dream in multiple stages of sleep, that it's not actually only during REM sleep, though that's when our dreams tend to be the most vivid. What's interesting is we don't actually know how dreams relate to these processes of memory, sort of storage and replay that I just told you, that this is an area of active research. There are a lot of theories about what dreams are for, but there's actually very little empirical evidence to sort of back up those claims. But there has been some work showing that the content of dreams may reflect this consolidation process during non-REM sleep. In other words, that these dreams might be sort of a byproduct of this process of sort of storing in this across region interactions that allow you to store memories. By nature of sort of reactivating those memories, that may lead into what we dream about. But that being said, we have a lot more work to do to understand anything about this relationship between dreams and consolidation or the storage of memories. And partially that's because it's just very, very difficult to study. And then lastly, I wanted to sort of zoom out a little and just talk a little about how sleep changes really drastically across our lifespan. So here I'm looking on this figure, what you're seeing is the proportion of those stages of sleep, sort of makeup of your sleep from conception to age 90. And what you see is that as we age, we end up getting not just less sleep. So that green part of awake is getting, you can see it increasing, but it also shifts towards less time spent in REM sleep in particular. And some work has suggested that these changes in sleep may be related to our changes in memory that happen as we age. So for example, at least a few studies have shown that changes in those stages of sleep or the underlying oscillations or brain waves that I was telling you about are actually related to worse memory retention in older adults. But what this basically just suggests is that sleep is very dynamic and it's critical for our ability to remember information that we've experienced. And to sort of talk a little about the converse of what I've just been telling you about the benefits of sleep, I wanted to also mention the adverse effects of sleep deprivation. So not sleeping can have really severe impacts across our cognitive abilities on lots of behaviors and processes. So decreases resulting from sleep deprivation include in attention, in working memory ability, in test-taking ability, your ability to process emotions, optimism, sociability, and as you probably have guessed from the rest of what I've said, the ability to encode or learn and retain new memories. Similarly, sleep deprivation has been related to increases in irritability, impulsivity, risk-taking behaviors, and the desire for caloric foods. Interestingly, a common myth is that you can't really make up sleep deprivation debts with a nap the next day or by sleeping later. In reality, the brain doesn't totally work that way. The best thing that you can do is to just go to sleep at your normal time so that you can maintain your circadian rhythm, what I was telling you about in the very beginning, because this is that 24-hour cycle that helps mitigate your sleepiness, your wakefulness. And because the brain has these very finely tuned cyclical stages of sleep, you can't ever just sort of slip into, getting just a little bit to make up for your prior sleep. And with that, my part is done. So I'm going to stop sharing and let Dr. Murty take it away.
Hi, everyone. Let me just get my old Zoom set up. Okay, so Emily did an awesome job sort of giving about the foundations of sleep and sort of ended on the note of sort of some of the maladaptive things that it could do. And I was gonna pick up from there and talk a little bit about mental health and how sleep intersects with mental health. And what's really sort of exciting is that for as much as we know about sleep in memory, and as much as we know about sleep in different mental health disorders, the like triumvirate, like the missing picture of the bridge of the relationship between sleep, memory, and mental health disorders is still this like wide open field and sort of active questions that Emily and I are pursuing in our own research, like as we speak, like ongoing studies on this. But what might be fun for people in the audience is to, speculate on some relationships or overlaps that you could see that sort of might relate some of these things with each other. I'm basically asking you all to inspire our next lines of research by connecting the dots. Okay, so we know that disturbances in sleep can influence a variety of cognitive and affective factors. Emily just gave you a laundry list of all the things that sleep affects. So it shouldn't be this big of a surprise, but disrupted sleep quality is pervasive across mental health disorders. You could really spin a roulette wheel of mental health disorders and you're likely to land on something that also has sleep disturbances associated with it. And what's becoming more and more apparent is that this is less likely a side effect or a symptom in a lot of these mental disorders, but actually might be one of the major contributing agents to those symptoms that you see associated with mental health disorders. So what I thought I would do is first, just sort of highlight a few that are known to have really prominent sleep disturbances in it. So we know in depression, a very, very common symptom in depression is early morning wakenings, right? So individuals waking up sort of 3 to 4 hours before they actually want to get up and not being able to fall asleep. Also in depression is the flip end of this, of spending too much time sleeping and not being able to get up when they want to get up. We know in post-traumatic stress disorder that there's a huge high occurrence of nightmares in this population compared to individuals that don't experience PTSD or haven't been exposed to trauma. And they think that a lot of these nightmares reflect some of the pervasive nature of negative mood and affect and stress and hyperarousal and sensitivity that's associated with this disorder. Emily also hit on circadian rhythms quite a bit and how that's intimately related to sleep. And there's many theories about how bipolar disorder might have to do with disruptions in the circadian rhythm. And in these cases, sort of the disruptions in circadian rhythms appear before you see symptoms in bipolar disorder. So as you can see, it's pervasive across a lot of different domains. What I want to do today was zoom in on one area, mainly because this is the area that we study in the lab. So I know a lot more about this than the other things listed here. But I wanted to zoom in on psychosis because there's been some really interesting work done with sleep disturbances and psychosis. So you might be asking me, what is psychosis? There's this also common conflation of psychosis and schizophrenia, that they're the same thing. So I just wanted to highlight a little bit about what psychosis is. It's an episode that can broadly be thought of as where one is detached from reality. It can appear in a lot of different conditions, including depression and bipolar and schizophrenia. Different drugs can induce it, but it's defined a lot by something that's called positive symptoms. So things like hallucinations, delusions that occur, disorganized thought and behavior, agitation. These sort of all fall into the compass of psychosis. To differentiate this from schizophrenia, which is more sort of a disorder that a psychiatrist or a psychologist would give, is that all of these symptoms of psychosis sort of fit into schizophrenia, but there's additional things in schizophrenia that might include disorganized speech, catatonic behavior, and these sort of negative symptoms of lessened emotional responses. But the reason I wanted to focus on psychosis is because it really exists on a spectrum, right? So on one end, there's a really high degree of psychosis symptoms. This is often apparent in disorders like schizophrenia, but they're also sort of pervasive across the entire population of individuals. So you can have these groups of individuals that are at clinical high risk for psychosis, which means, they might be showing sort of attenuated symptoms, but they're not all the way into a psychotic episode. And then you also have individuals, and this is really spread across the population, of psychotic-like experiences, right? So you might be feeling one or two things of psychosis for intermittent periods of time, but you're not sort of in a full-blown episode, right? And the reason I wanted to bring up this spectrum is because I wanted to, connect to the audience. And it's very likely that, if not 95% of us in here, it could be all of us, have experienced something close to a psychotic-like episode in our everyday life. And it gives us a little bit of a leverage to sort of understand these processes and help sort of bridge the empathy and understanding that might happen with individuals with diagnoses with schizophrenia. So I'm really going to focus on telling you a few things about psychotic-like experiences as well as individuals that are at clinical high risk, because these represent, our population. Like 10% of a college population would fall under the category of clinical high risk for psychosis. So what we know from sort of a broad set of literature is that individuals at clinical high risk for developing psychosis have general sleep disturbances. They have fragmented nighttime sleep, and often they have more occurrences of nightmares than their peers. Just to make this a little bit more tangible in terms of what it might feel like as an individual that's experiencing these types of sleep disturbances, it might be, when you wake up and you feel like you had a really restless night of sleep, right? You're moving a lot during your sleep, or you're not getting fully refreshed by your nighttime sleep, so you end up with more daytime naps, or you go to bed and you have a harder time falling asleep when you're in bed. These are the types of sleep disturbances that are apparent in these individuals that are at risk for developing psychosis, as well as a lot of other psychiatric diagnoses. The one thing that's particularly interesting about psychosis is Emily talked about these sleep rhythms, the ones that were sort of especially important for episodic memories, that ability, to like recall what your high school graduation looked like, or your 30th birthday party, these sort of rich episodes about the world around you. And in psychosis, there's specifically a decrement in these sleep rhythms that reflect memory transformation and the things that Emily talked about. This is where I said, it's really easy to want to start speculating and making connections across the board, because when you think of things like delusions or paranoia, right, it's very easy to see how those might be related to a deficit in episodic memory that might be happening. If you're transforming them in a way that's not the most adaptive way, that could set the framework and groundwork of where delusions and paranoia come from. But warning, hands up, we're not there yet with the science, but I think there's a lot of natural areas of overlap that can make some pretty strong theories. Okay, you might be, when I first heard about sleep disturbances in psychosis populations, I was very much like, okay, if I spent the day having delusions, having paranoia, being agitated, of course I'm not going to be able to sleep, right? Like the symptoms themselves might be the thing that's disrupting sleep, which sort of brings up this age-old problem of the chicken and the egg of what's coming first, right? Is sleep just disrupted because you're feeling all these symptoms of the disorder? But what's interesting is in psychosis, it really seems like sleep disturbances might be preceding and predicting symptoms of psychosis. So first, if you look at individuals that sort of have had an episode of psychosis before, but they're in remission, often the sleep disturbances will predict relapse into their next psychotic episode. So it seems like the sleep disturbances are coming first. Similarly, sleep disturbances are prominent in these individuals like clinical high risk for developing psychosis. That means this is a group of people that do not have psychosis yet, but they're just at greater risk for developing it later. And these individuals also show sleep disturbances. And finally, if you just sort of take a college-age sample, the secret is we use a lot of college-age samples because they're easy to recruit in studies when you work at a college. But if you sort of take this random sample of 18 to 25-year-olds, often sleep disturbances will predict psychotic-like experiences in this more normative population, right? So again, I'm sort of talking in really like terms that might feel distant or harder to connect with. So I wanted to zoom in on one experiences, which is the dissociative experience. This is a really common feature of psychosis. It's also very prevalent in other diagnoses like PTSD and trauma. And what it is described as is a disconnection or a lack of continuity between thoughts and memories and surrounding actions and identity. I found this artist, Elizabeth Tremblay, who has a wonderful blog, Scribbling with Spirit, about her path through trauma recovery. And she's basically blogging about putting together a memoir, a visual memoir of her experience through trauma, and had this sort of draft of a visual that she was using of like, how do I even relate this experience to the public as people are reading my memoir? And came up with this thing of sort of, you know, your body's there and you're interacting with the world, but then it's sort of connected or tethered to this blimp where you're watching yourself act. There's like a tethered disconnection from the way you're experiencing things. The reason I bring up dissociative experiences is because A, they're very prominent in psychosis. And if you have greater sleep disturbances in psychosis, you're also more likely to have dissociative experiences. But the real reason I brought it up too is that I wanted to connect with every single person that is here listening to this. I think that many of us have felt the experience that we're sort of, you know, on a 2-day bender from work, operating off of like 4 hours of sleep, and you start to feel this sense of dissociation, a little bit that you're sort of watching yourself come out of it. If you haven't felt that, if you've ever sort of been in a really deep sleep state and somebody wakes you up immediately from that sleep state and you have this sense of like, where am I? Wait, what house am I in, right? That is sort of something that's in the family of dissociative experiences. So I brought this up just to sort of draw a link of how the two things might relate that feels a little bit more personal. So, you know, coming off of the end of Emily's slides and sort of the beginning of mine, there's sort of this like doom and gloom narrative of like, oh no, you're not getting sleep, but things are going to go wrong for that, and it might actually be a contributing factor to psychosis. But what's interesting is that this is something that might be able to be an intervention or a target for remediation. So this study just came out recently, and I'm sorry the resolution's so bad on it. I just wanted to zoom it in so you can see the numbers really big, where they took individuals in this clinical high risk, the individuals that are sort of, you know, feeling these sub-threshold symptoms of psychosis, and had one group of people, both groups of people, they underwent this therapy that sort of helps restore sleep. It's called sleep cognitive behavioral therapy. And what they found was that it decreased paranoid thoughts and psychotic experiences in these groups of individuals. And interestingly, it didn't really do anything immediately after they finished the therapy, but when they did a follow-up 6 months later, that's when they started to see these massive differences. And I just bring this up because fixing your sleep can basically set the trajectory for these sort of life-altering changes that can be predictive, right? So if you're sitting in the audience right now and you're like, oh my gosh, my sleep is terrible, what am I gonna do? I can't turn it around. Like, you can turn it around. There's ways to fix it, and there's restorative benefits to it when you see it in psychosis and more broadly. So the last thing I wanted to end on is that it might be that you're hearing this narrative from me that's like, okay, these sleep disturbances lead to psychosis and psychotic symptoms. Here is a better depiction of what the world of mental health research looks like. There is multiple causes and they all interact and they're all overlapping. And it's really hard to tease apart what's doing what, which is why Emily and I research these types of things is to help untangle these knot of causal factors. And just for instance, I wanted to give this example in the psychosis research is more recently it's been shown that the reason why psychosis symptoms might be getting bigger with sleep disturbances is actually because the sleep disturbances cause things like depression and stress, and the depression and stress might actually be the actual risk factor that's leading to psychosis symptoms. So I gave you sort of a skim the surface of the web of what's happening on, but I also wanted to end with reflecting on how complicated and complex a system is. So the very last thing, and Emily and I talked about this beforehand, we are not medical professionals. We are research scientists that work in a lab, right? So we're really excited for questions. But if you really want to know the types of interventions, like there are websites, I highly recommend the National Sleep Foundation that have, really powerful interventions on how to restore your sleep. And I think Emily and I are happy to comment on some of these interventions and why they might work. But I double want to emphasize when we comment on them, we are commenting them on as a peer and not as an expert. But if you want to talk about like theta oscillations and how they reflect integrative encoding, we're game for that to talk as an expert. So on that note, I'm going to stop sharing my slides and then we can swap over to the Q&A section, I think.
Awesome. Thank you so much. Both of your talks were so cool and so amazing. And I learned so much. So I prepared just like the briefest of lists from a book I read from another sleep thing. I'm a squid biologist. I don't know the first thing about sleep, but I'll also put up a list of things that people say you can do, and we hope you can do too. Who can share? Sure. Let's see. Whoops. It is not letting me share my screen. So,
oh, can we switch it over to you? Maybe let me see if we have.
Let's see. I think I'm the host.
See if you can do it now.
I can. I can. So I read this book, and I'm going to go to the next slide so I can talk about the book briefly, because we are teamed up with the library, and I got this book out of the Philadelphia Library on audiobook. It's Why We Sleep, Unlocking the Power of Sleep and Dreams. So if this is the kind of thing that you are interested in, this book is honestly scarier than the presentation that we just heard today. It is like, if you don't sleep enough, here are the hundreds of horrible things that will befall you. And it didn't even touch on the mental health stuff. Maybe it did, but the most scary parts to me were like, you shouldn't drive tired, and how scary that is. That's what I think I remember the most. But there's lots of things that we can at least try to do in like a sleep hygiene kind of way. So sleep hygiene is not everything, but it is what I'm going to talk about right now. So things I learned from this book is that I shouldn't be shining ring lights directly in my eyes right before bed. Like I shouldn't be doing this to get a good night's sleep tonight. I shouldn't be looking at my phone before I go to bed, despite the fact that the last thing I do before bed every single night is play a game with blocks. I'm not supposed to drink before I go to bed, which on Fridays and Saturdays is unrealistic for me, but what are you gonna do? And that I should knock it off with my afternoon naps, because you two are gonna know what that chemical is that builds up in our brains during the day that makes us sleepy and eventually go to sleep. But if you take a nap in the middle of the day, you basically flush some of that out, and so you don't have enough when you go to bed at night. Don't drink coffee after noon. I've stopped at 11 a.m. because I am a bad sleeper, and the half-life of caffeine is, I think, like 4.5 hours. So that means that when you drink coffee in the morning, if you're drinking, let's say 100 milligrams of coffee, that's of caffeine inside the coffee, you're still 4 hours later going to have 50 milligrams floating around in your blood, still active, and half of that 4 hours later. And so if you drink a gratuitous amount of coffee in the morning, you're still going to have a fair amount when you're trying to go to sleep. So take that into consideration. And also, I know this helps me, cooling down the room is apparently supposed to help you sleep better. So again, I'm super duper not a doctor too. I am a squid biologist, but I did read that book, and that gives me absolutely no credibility whatsoever. But if you want to read the book too, I thought it was great. They have it at the library. And let's do the Q&A now. I'll stop streaming and then we'll share this other useful stuff at the end.
Just as a quick note, is speaking of.
Oh, Raven, your audio went off.
There we go. I got there eventually. Speaking of things we have in the library, you'll notice a barrage of links to all of the resources that I just shared in the chat. We have Why We Sleep, both in physical, e-audiobook, and e-book, e-regular book, e-Kindle book, as it were. As well as a couple of other sleep-related books that I have shared in the chat. So if you end up wanting to link straight to how you can get these resources for free, I got you.
We love resources for free. And if you're not in Philadelphia, your local library may also have it as well. Awesome. So let's get into the Q&A. Thank you all for bringing your curiosity with you tonight. So I'm also Raven, you might have to resend those, but instead of sending them directly to me to everybody. Right. Okay, so our first question comes from Ashley. On the topic of sleep and memory, how do we better help students, particularly teenagers, who don't get enough sleep and are then expected to recall large amounts of information? Are there any tips for balancing studying with sleep?
This is a great question, right? There is sort of a lot of people, this is part of the reason there's a big push to sort of move school time, start times a little later, particularly because, I showed you those in general, the pattern of sleep, but what also changes is things like your circadian rhythms of how much sleep and your patterns of sleep change. And so this is a great question. One of the things that we also study is generally how sort of memory, even separate from sleep. And one of the things that is always, this is sort of separate from sleep, but it's always better, it's always worse to cram for things. So if there's been a ton of work showing that, and this, I think we all know it, but there's a lot of science backing it up, that spreading out your learning experiences or your repetition, or if you're testing yourself or what have you over multiple periods versus trying to get it all in at once is always a better way to actually make a more long-lasting memory. And so if it does come down to, staying up and cramming versus sleeping, the reality is it's obviously it's not a great situation to be in, but if you can distribute that learning or your sort of memory, ability to remember sessions as much as you can, sleep is going to help you, remember, but, cramming isn't particularly a great option. It's not a, I don't have any great solutions. I think this is a problem that's been, forever, but yeah.
Awesome. Thank you.
And then if I can just plus one that a little bit, it's funny, Sarah, you brought up at the beginning, like, oh, there's no activism in the domain of sleep. I so strongly disagree. If you read these things and care about it, like, we need to be reaching out to our local governments and local school boards. The detrimental effects of having school time start so early is shown to have mental health consequences, learning consequences across the board. So I would say there is a point of activism there about becoming more vocal in that space. And the other thing too is that I think we just need to inform teenagers and students more. So when they're thinking about that decision of how they want to distribute things, it comes to it. And this other sort of new wave of research comes to mind too. So like Emily talked a lot about how like the sleep will enhance your memories, right? And sort of stabilize them. But the other thing sleep does is sort of clears out all the mess that's accumulated during the day. So when you're sitting at a test, one part of the problem is that you don't have the memory stabilized. The other part of the problem is that there's like so many memories. So you're like the Google search engine that's trying to find the one memory you need for that fact, but there's like all this noise around it. Sleep also helps you sort of clear out some of that noise. So you're starting with a fresh start. And I think the more we can sort of inform students about these processes, like give them the agency to make their own choices, and like, hopefully they make the ones that are better for them.
Awesome. So that means that the action item that I'm leaving you all with, all of you at home today, I want you to write to your local school board and tell them to start school later. I would have appreciated that as an 18-year-old. And I bet teachers would appreciate it too, because my God, too early. All right, the next question is from Gabrielle. Is there any research on how daylight savings time affects mental health at the population level? Great question.
I don't know. I mean, the work I've seen is a lot about sort of the opposite side, which is like sort of a sleep question or not, but there's this idea that if you don't have enough exposure to daylight, that can actually disrupt your circadian rhythm. So then down the line, it's all like this chain of 100 things that sort of topple on top of each other. Then that can actually cause sort of sleep disruptions because you're not getting enough daylight activity to set those circadian rhythms. So I think there is some evidence that, shifting daylight time to give us more exposure to sunlight should be beneficial. The really hammering point that's shown this is places that sort of have these like 18-hour night, like no sunlight days. And they have seen sort of massive population level seasonal affective disorder from those.
I will jump in as a converse, I guess, to that a little bit. Is only just, I think we probably all kind of know this, that you do kind of feel a little jet lagged after daylight savings. So speaking a little less to the mental health aspect, we know I think there's evidence that car crashes increase after daylight savings time changes. And so there is, which is, terrible. But we that it's an hour, but it makes a huge difference because of those circadian rhythms. It's shifting our amount of time we're getting of sleep. It's shifting things around. And so I'm sure it does have some, that immediate period of daylight savings days or day after probably does have, I wouldn't be surprised if it has some, adverse effects.
Maybe like that day, that week. I think heart attacks also go up that day. Weird, very weird. Okay, the next question is from Tiffany. Why can we sometimes remember what we dreamed and other times we can't?
So this is a lot to do with waking up. So one of the things that I think I didn't appreciate until I started studying sleep is how often we wake up during sleep. And these are really small awakenings, not where we're aware, opening our eyes, conscious. They're really, even milliseconds or seconds of sort of going up, if you remember that graph I was showing, going back up to that wake period and then going right back into your stages of sleep. But what happens during that is, and we've probably all experienced this, where we tend to remember dreams more that we have right before we wake up. And part of that is when you sort of the idea is that when you're waking up during a dream, you're more likely to remember it because it's sort of what you're just experiencing. Again, there's a lot of questions about, what does that mean for accessing those types of dreams later on? Why can't we? I don't know the answer to that. I think it's super interesting, but yeah.
All right. Thank you for that. The next question is from Harag. I've recently gone through a traumatic event and have been getting restless sleeps and extremely vivid dreams. Why does this occur?
I can take a stab, Emily, and then you can correct me when I get around. Okay, so it's interesting. We know a lot about why emotional memories form and how traumatic events can get really vivid, and we know a lot about emotional memories and sleep. But then again, the full triangle is a little bit missing. But as a best guess, and this isn't like a solid firm, like when you have a traumatic event, your body goes through sort of like a hyper arousal, right? Like your stress hormones go up, norepinephrine's going up, which are adrenaline, like normal people say, your adrenaline goes up. And all these things sort of foster plasticity in these learning systems, right? So you're sort of laying down these original traces that might be like very, very primed to undergo the things that Emily talked about, like replay, right? So the fact that something important happened, like think how adaptive this is in the world. A very important thing happened. We want you to nail this memory down because it's very important that you nail it down, right? So sort of this flood of like neurohormones sort of comes out during the event that could be tagging the memory to say like, replay me at night, right? Like this is the things that you need to replay because these are important things that we need to stabilize in memory. And that could be sort of the first wave of why it's happening. But what's interesting is that when you look at individuals with PTSD, this system might have just gone too far, right? Like the knob got turned up too high, and there's sort of states during sleep, I think particularly during REM, that your stress hormone activity is reduced, right? But when you're an individual with PTSD, that switch doesn't turn off, right? So it might be that they're even getting more hyper aroused while replaying it, which is sort of like, okay, a very adaptive system that we all want to have happen is just turned up a little bit too high. But I think that would be my best guess, is that the arousal in the moment that it's happening is tagging the memory of this. And actually, Emily just wrote a beautiful paper on this theoretical model that just came out if people want to like dive deep into the neuroscience of it.
Awesome. Perfect. Cool. All right. The next question is from Ashley. How do sleep disorders such as sleep apnea affect memory?
Do you wanna? Okay. This is a good question. And I think this is one where it hits a little on, I don't have a ton of experience with sort of sleep disorders in terms of, there are definitely people studying this. And as far as I know, there's some research showing that there's sleep, there's other disorders, including sleep apnea, that can cause more awakenings. They can reduce the amount you're sleeping. Obviously, insomnia is another one that's, a big question. And I think there have been a few studies that have shown a relationship, sort of a correlation between the disorder and later memory, but I don't know those studies well enough to make a strong claim. But based on everything I've said, particularly I think with apnea, there's this question because you're not necessarily fully waking up. So I'm not sure about that one entirely. But it is a really interesting, very, very, very important area for research.
Yeah.
And then I just always like to take this opportunity to like highlight the hyper complexity of doing research too. And this comes in with sleep apnea, is that like, here's a thing that happens and changes 15 things that are all interconnected with each other. So trying to figure out like what came first or what's causing what. Is it disrupting attention and then the side effect is the memory, or is it disrupting memory and then the side effect? It's very challenging to unpack the order of events.
I don't envy that job. That sounds very confusing. Thank you. The next is from Pablo. Is there anything that can increase SWS and or REM sleep?
Great question. And one that a lot of researchers are wondering about too, because obviously one of these questions is, are there ways to sort of interventions on sleep that would then benefit memory? And so far it's a little unclear. There are some like very, people are seeing how different ways of like, it's hard to, very like research, not, it's a little like sci-fi of, you can like play certain frequencies that will then increase that frequency. One of the things but it's not really used yet. One of the things I can say is there is some interesting research suggesting there are certain medications that can increase some of these oscillations that I mentioned. And those have been shown in a couple of papers to have a benefit on memory. Of course, it's really unclear if that's having other effects, and we're not there yet, but it's certainly an area of research.
Where we are there, which is going to seem like a silly answer to this question and probably not the one that the question asker was looking for, is they do a lot of these interventions. Okay, so as Emily showed earlier, your transition into these things happen with longer periods of sleep. So you need to get sleep. Like, it needs to be long enough to get there. So there's been some cool intervention studies in adolescents that is basically showing that, like, stay in bed, like get in your bed earlier, just to extend the amount of time of sleep that you're doing. And then when you extend the amount of time of sleep you are having, then you incidentally increase all these important markers. So sleep hygiene, sleep hygiene, sleep hygiene.
Awesome. That was also mentioned in the book that even if you don't think you're sleeping, if you're in bed, that is better than walking around the house, which is not intuitive to me. I always think if I'm just sitting there staring at the ceiling, I'm not doing anything useful, but I guess I'm wrong. I guess we should be in bed, just trying our best.
There have been a couple of studies, again, this is like, a few studies, but there have been a couple of studies that show that quiet wake, restfulness is better than wake for some of these factors. So definitely, +1 to that.
Cool. Awesome. All right. And then we have time for one more question that we'll try to make a short one from Tiffany. Do melatonin supplements really work in helping a person sleep better? And if so, how much do you need?
I'm going to take this one with a hard pass. Ask your doctor. This is the warning that, like, we are not clinicians and sort of like have no business in that area, because I think there's certain circumstances that it's beneficial and other circumstances that aren't, but like you have to like have a rich tapestry of what your overall health is.
Cool. Yeah. Ask your doctor. We don't know. Awesome. Sounds good. Well, thank you so much, both of you, for sharing your knowledge. Thank you, Kay, for signing. I am going to put up some information here. All right. So our next Science for Change session is going to be on October 20th at 7 p.m. We're going to be talking about the opioid epidemic in Philadelphia and beyond. We have a scientist to help us understand what goes on in the brain during an opioid use. We're also going to hear from an activist who is helping with a lot of things around opioid addiction in Philadelphia, including getting naloxone, which is I forget the common name for it, but what can revive a person after when they're experiencing an overdose. So you can get that in Philadelphia if you are around users of drugs. And that
can, and there are tons of free local trainings that will get you set up with kits. And I would suggest it even if you're not around people who use drugs, because we live in Philadelphia. Well, I live in Philadelphia. Maybe you don't.
We all live in Philadelphia. Yeah.
You never know when it might come in handy.
Yes, I did the training and it was easy. And during this session, we will give you all the information on how you can get the training too. So we'll be all good to go there, because it's easy to use and you could save a life. So there's that. Once again, we can read that book, Why We Sleep. And if you can support these sessions, we would really appreciate it. Skype a Scientist completely relies off small donors. The average donor to support our program is about $11. It's like $11.80 is the average donation to our program. And we don't have any major grants to exist. We completely rely off people supporting us. So you can do that at patreon.com/Skype a Scientist. We also have trivia every single Thursday night, and you can join the trivia tier to go to that every week, or just show up 1 week. You can find out all about our future live streams, both for kids and for adults, and our trivia at skypeascientist.com. We hope to see you next month. Thank you again to everyone who participated and organized this event tonight. And thank you for coming. We really, really appreciate you. If you have something that you'd like to see in a future Science for Change series, email us at skypeascientist@gmail.com and we will work on making that happen. Does anyone else have anything they'd like to say before we wrap up? Cool.
I'll just say thank you so much to you, Sarah, and Raven, and everyone for organizing this. And thanks everyone for coming.
Yeah, the questions were great. It was a lot of fun.
Awesome. Yeah, thank you again. Okay, well, we will see you all next time. Thank you again for coming. Have a good night.